I am Dr. J.L. Mazher Iqbal, Professor ECE Department. Today's lecture is Embedded C Programming using 8051 microcontroller. First, I want to discuss the pin diagram of 8051 microcontroller, which consists of 3 ports. Okay? Port 0, port 1, port 2 and port 3. So here the embedded C programming is very popular software programming, so used for programming of various gadgets such as mobile phones and the LEDs may be connected. Okay, LEDs or other output device can be connected and we can able to toggle it. Okay, the programming here, the program starts with first we need to include the header file hash include register 51.h void main, and then start the for loop. The for loop will be forever. We can use while loop or for loop. If we give port 1 is equal to 0x55, then the LED will glow 101 101, and then port 1 is equal to 0xAA. Okay, so it will continuously toggle. Here 0x55 in port 1, again 0xAA, it will continuously toggle. This is a very simple program for toggling the LEDs. And then previous program there was no delay in it, so we need to create the delay. So this program will create the delay. So write an 8051C program to toggle single bit of port 2 continuously with 500 millisecond delay. Okay, so now port 2 is declared here as single bit LED, and the program starts with integer main LED is equal to 0, that is configuring as output pin, and then start the for loop. The for loop is forever, the loop is continuously executing forever, and then LED is equal to 1, so call the delay of 500 millisecond and then LED is equal to 0. Okay, so LED will blink. In between that there will be a delay of 500 millisecond. So next, how to create the delay of 500 millisecond. The next slide, next program. Now delay program. Here the delay program, we need to declare the function void delay unsigned integer item, unsigned integer I comma j. So here 2 variables are declared. Now create delay. Delay is created by creating the empty loops. For I is equal to 0, I is less than item I plus plus. Now item will be 500. So this loop, the second loop, for j is equal to 0, j less than 1275, j plus plus, it will create a 1 millisecond delay. Whatever the items will give, it will create more 500 means 500 times this loop will execute. So it will create 500 millisecond delay. So the next program is write an 8051C program to get a byte of data from port 1, wait a half second, that is 500 millisecond, and then send it to port 2. It's a very simple program. So the program starts with including the header file and the delay function is declared. Then void main void. So void here means the main function will not return any value here. So then unsigned character my byte, port 1 0ff, and then for loop will execute forever. First port 1 receives, my byte will receive from port 1 and a delay of 500 millisecond, and then the my byte will be transmitted through port 2. Okay, then delay will be 500 millisecond. So a delay program of 500 millisecond delay. So previously we have created delay for 50 millisecond. Now we are creating the delay for 500 millisecond. Okay. So now a program, now a door sensor is connected to the port 1.1 pin, and a buzzer is connected to port 1.7. Okay. Then write an 8051C program to monitor the door sensors. The door sensor will be monitored if the door sensor is activated, and when it opens, then we need to sound the buzzer. Okay, that is the program. sound the buzzer by sending a square wave. That is the question. So sound the buzzer by sending a square wave. The program starts with including the register file register51.h, then declaring a function, delay function. So D sensor, that is door sensor, is connected. Now assume that door sensor is connected in port 1.1. And then the function start with void main void and door sensor, which is connected in port 1.1, which is equal to 1. And then keep on checking with the help of while loop while door sensor is equal to 1. If door sensor becomes, that is door sensor is equal to 1 means the door is open. Okay, when the door is open, then buzzer has to be activated. The buzzer is activated by giving a square wave. So for giving a square wave, 0 and 1 is given with the 200 millisecond delay. Okay, 0 200 millisecond, 1 200 millisecond. The 200 millisecond delay can be created from the previous program only. So void delay unsigned integer items. Now delay is created in the same manner like previously. Okay, so item will be here 200 millisecond, so this will give 1 millisecond delay. Okay, next to timer programming. So timer programming, which gives the exact delay. Previous programs with the help of for loop, empty for loop, it gives approximate delay only. The timer programming will give exact delay. How to calculate the delay in using timer of 8051? So 8051 C program to toggle only bit of port 1.5 continuously for 50 millisecond. Now 50 millisecond delay will be created using timer. Okay, use timer 0 mode 1 to create a delay. So consider the crystal frequency of 8051 is 11.059 megahertz. Then machine cycle frequency can be calculated as 11.059 divided by 12, which is 921.6 kilohertz. So this crystal frequency can be obtained from the data sheet of 8051 microcontroller. Sometimes it may be 24 kilohertz, sometimes it may be 11.059 kilohertz. So one step delay can be calculated as 1 by f, which is 1 by this 1.08 microsecond. Okay, 1.085 microsecond. In order to create 50 millisecond delay, so 50 millisecond divided by 1.085 microsecond, which is 46083, which is a hexadecimal decimal value. It need to be converted into hexadecimal. The hexadecimal value here, so here 4603, the maximum step is 65535 plus 1, which is FF. So it need to be subtracted with this value, so that we get 19353 to the base 10. It's converted into hexadecimal, that is 4B5FD. So this value to be loaded in the timer register. So once we load this value into the timer register, we will get this delay. We will get a 50 millisecond delay. Okay. So now the value of the T mod, because we are going to select mode 1 here. Mode 1 timer 0, mode 1. So if you select timer 0, this bit has to be written, otherwise this bit should have been written. Okay, 0 0 0 0 0 0 0 1. So 0 1 means it is mode 1, 0 0 mode 0, 0 1 mode 1, 1 0 mode 2. Okay, so here mode 0 is 13-bit timer, mode 1 is 16-bit timer, and mode 2 is 8-bit timer auto reload. So now if we have selected 0 1, so that's why it is a 16-bit timer. Okay, next. So now we write a program. So T mod will be 0x01. 0x means it is hexadecimal value. So the program start with including the register file, then S bit declares port 1.5 void main void, and then T mod while 1. So it is a for loop. Okay, like for loop for 2 semicolons, it will be executing forever. Now this while loop will also will be executing forever. So my byte, which is port 1.5, so my byte is equal to not of my byte, that is it's toggling. So delay, now delay will be delay will be created using timer. So delay program using timer, 50 millisecond delay, void delay. So T mod, which is in mode 1, and the value to be uploaded is 4BFD, what we have calculated for 50 milliseconds. So the initial value of the timer register will be 4BFD to create 50 millisecond delay, and then the timer should start running. So by giving TR0 is equal to 1, which is there in the TCON register. So while now we are checking that TF, that is the timer flag is activated, set or not. Okay, if it is not set, that is TF is equal to 0, this loop will be executing continuously. So once TF will become 1, TF0 will become 1. That means the timer has overflow. Okay, if there is overflow of the timer, then it comes out of the loop, while loop will end, and then TR0 will become 0. That is, timer is getting stopped. Okay, so that is the program here. As a programmer, we can stop the timer. As a programmer, we can start the timer. So the timer is started here. When there is a overflow, timer is stopped. Okay, then flag also will set to 0. Okay, so this function will create 50 millisecond delay. That delay will be the exact delay for 8051. Then 8051 C program to toggle only bit port 2.1 continuously every 500. Now we need to create 500 millisecond delay. Previously 50 millisecond delay we have created. So using timer, we can create a 500 millisecond delay. Now use timer 1 and in mode 1. Mode 1 is 16-bit timer. Okay. So the maximum step delay for 500 millisecond, we have to create 500 millisecond. The maximum step delay is 0000 to FFFFH. Okay, so FFFFH, if it is converted into decimal value, it will be 65535 plus 1. So the maximum step delay is 65536 is the maximum steps. So into one step delay already it is calculated at 1.085 microsecond. So which is the maximum step delay is 71.1065 millisecond. But we need more than this 71 millisecond, which is 500 millisecond. Then if we multiply this with 7, we will get 500 millisecond delay. So we want 500 millisecond delay. The program starts with including register 50 including the header file, and then similarly declaring port 2.1 as single bit, and then integer main LED is equal to 0 configuring as output pin. The loop for loop is running forever. So LED is equal to 1 delay. Now it is toggling. It is toggling with delay of 500 millisecond. So the delay of 500 millisecond, how to create the delay of 500 millisecond? Void delay. Then we have to load 00 in the initial value of the timer. So timer is 0x10, it is timer 1 is used. Timer 1 in mode 1. Then the 7 times this loop will execute. The initial value we have to load is 00 and 00 in TH1 register and TL1 register. So that the initial value is 00, maximum 71.05 millisecond delay this loop will create. One loop will create 71.05 millisecond. Timer start running and it will check whether the timer overflow is there or not. If there is overflow, stop the timer and reset the flag. Okay. So since 7 times this loop is executed, 71.05 into 7 times, so it will give 500 millisecond delay. So exact 500 millisecond delay using timer register. Then create a square wave on port 1.5 bit. Use timer 0 to generate the time delay. Assume the frequency of the square wave 2 kilohertz. So a square wave should be, the question is create a square wave of 2 kilohertz. Okay. So 2 kilohertz. So what is the time period of that square wave? 2 kilohertz is 1 by 2 kilohertz, which is 500 millisecond delay. Square wave means on time and off time. So we have to create on time. We have to determine how much delay is for on time and is for off time. So for a square wave 50% duty cycle, on and off time, which is equal to 500 microsecond on and off together. So now only on time or off time, which is 250 microsecond delay. So we need to create 250 microsecond delay now. So in order to create 250 microsecond delay, 250 microsecond divided by a step delay, which is 1.085 microsecond. Okay, frequency, step frequency is 1.085 microsecond, which is equal to 230. So now the maximum value of 16-bit value here is 65536 minus 230, which is going to be 65306 to the base 10. Once it is converted into hexadecimal, FF1A. So this FF1A to be loaded in the timer 0 register, timer 0, TL0 and TH0 register. Once you load this value, the initial value this one, the maximum value FF. So we will get this frequency 250 microsecond. Then writing the program to generate the square wave of 250 microsecond delay. So which is include register 51.h, void delay, port 1.5 we are connecting, that is my bit. So void my bit, while 1 the loop will execute forever, and my bit is equal to not of my bit, which create a square wave. Okay. So delay and delay of 250 microsecond delay. Then the delay program is, so void delay. So we need to create that 250 microsecond delay on period and off period. So T mod is equal to 0x01. So we use timer 0 in mode 1. So the value loaded is FF1A. Okay, TH0 and TL0. Once we load the initial values by FF1A, we will get a delay of 250 microsecond. Okay. Then start the timer and then test the flag. If there is a overflow, it comes out of the loop. They stop the timer and reset the flag. Then the next question is, it is possible to ask like this: calculate the time delay generation. TL is equal to, if the initial value of the timer is 3E and B8H. Okay, that is B8 3EH. For that, how much delay will be generated? Okay, so T is equal to the maximum value is FF plus 1. Okay, so minus B8 3E, so which is 47C2H hexadecimal value. If you convert into decimal value and then multiply with the step delay. One step delay is 1085 microsecond. Okay, the one step frequency is 1.085 microsecond. If you multiply means we will get 19.931 millisecond delay. Okay, for the initial value of this B8 3E, so the timer will give this much delay. Now serial communication programming. So serial communication programming, we need to set the baud rate for serial communication. For that still we will use the timer. Okay. So timer T mode is 0x20, means timer 1 is used here in mode 2. Okay. So here timer 1 is used, this is timer 0 and this is timer 1. Timer 1 is used here 0010. It is mode 2 we have used, mode 2. Mode 2 means it is 8-bit auto reload. The timer will be 8-bit timer. So mode 0 13-bit timer and mode 1 is 16-bit timer, and mode 2 is 8-bit timer, 8-bit auto reload timer is used for mode 2, timer 1. And setting the baud rate, the formula for setting the baud rate is 2 power S smart into 11 point, this is the crystal frequency of 8051 microcontroller, 11.059 2 megahertz divided by 12 into 32, 256. So this will be the baud rate. We can calculate the baud rate. If S smart is in PCON register is 1, then FD value set the baud rate to 9600. Okay, 9600 baud rate we can set if it is 1. If it is 0, then the FA value set the baud rate to 4800. Okay. So 4800 the value is FA, for 9600 the value is FD. If FD is loaded into the timer register, the baud rate is set as 9600. If FA is loaded into as the initial value of the timer register, then the baud rate will be 4800. So SCON serial control register. So this is the serial control register. So this is mode selection, and then here receiving enable receiving if this bit is 1. Okay. So this is the these are the ninth bit. If we select 8 bits or 9 bit, if 9 bits are selected, that will be mode 2. Then this bit will be 1. So SCON is equal to 0x50 in this case. The mode 1 and then receive enable. So mode 1 selected, 8-bit UART selected here. Mode 1 means it is 8-bit UART. So it can be 9-bit UART or 8-bit UART with timer data rate. Then this is a program, serial communication programming. So So write a C program for the 8051 to transfer letter A serially. The baud rate is 4800. If we want to set the baud rate 4800, we need to load the initial value of the timer as FA, 0xFA. Okay. So for this the program is, so include register 51. So header file is included first, then tmod 0x20, that means timer 1 is used. Timer 1 is used in mode 2. That is 8-bit auto reload. So timer is 8-bit timer and it will be 8-bit auto reload. So TH1 FA, if the initial value of the register is FA, then the baud rate will be 4800. Okay. Then SCON is 0x50. Then the timer is started with 4800 baud rate. So timer started while 1. Then SBUF is a register. So where if we need to place the character to be transmitted using serial communication. So while Ti is equal to 0, that is if this Ti is 0, then this loop will keep on checking the timer interrupt. So if it is 0, then this loop will be executed. If this becomes 1, that is timer interrupt will become 1, then make the timer interrupt as 0. Okay, the letter is transmitted. Okay. So now a C program to transfer Vailtech serially. So with the baud rate of 9600 baud rate continuously in 89C51. So 9000 the speed is now 9600. So in order to set the baud rate 9600, the initial value of the timer will be 0xFD. 0xFD for setting the baud rate 9600. Okay. So you need to include the header file, then delay function is declared, void main void, then mode, we are using timer for serial communication. Okay. We need to set the baud rate of 9600 for a timer. So we use timer 1 in mode 2, and then the initial value will be FD for 9600 baud rate. Then SCON is equal to 0x50, where receiving and transmitting both are enabled here. Okay, the timer is started and the loop will be executed forever here. Okay, in order to transmit Vailtech. So first to transmit V, transmit E. Transmit is a function here. Later we will elaborate this function. Transmit V, transmit E, transmit L, and there will be a delay of 500 milliseconds. So the transmit function is elaborated like this. So void transmit unsigned character. This function return a character value. Okay, unsigned character X here. So here it receives X value. So X can be V, E, L, Vailtech. Finally it will be the Vailtech. So we need to keep each and every character. V first is kept in SBUF and V will be transmitted. After that E is kept in SBUF and then E is transmitted, like that. All Vailtech letters here the transmit function is called. Okay. So then we'll check this Ti is 0 or not. So if it is not 0, that means the letter is not transmitted. Okay. So once Ti becomes 1, the letter completely it is transmitted. Okay. So it will check whether the letter is transmitted or not. If the letter is transmitted, then Ti becomes 1. Okay. So next we make Ti 0 in order to transmit the next letter. V after E after L, like that. Okay. So this is the function. So delay can be generated using timer, or delay can be generated using empty loops. This may be approximate delay only. So exact delay can be generated using timer. So already discussed. Then interrupt programming. So there are 6 interrupts in 8051 microcontroller. So here we will use 2 interrupts, 1 interrupt and 2 interrupt. Then the program is write a C program that continuously gets a single bit of data from port 1.7 and send port 1.0. This is normal operation of 8051 microcontroller, while simultaneously create a square wave using interrupt. Okay, this will be the interrupt program. Square wave is the interrupt program here. So while simultaneously creating a square wave of 200 microsecond delay. So period on port 2.5, use timer 0 to create the square wave. So we are using timer 0 here. So assume the crystal frequency is 11.059 megahertz. Then in order to create the square wave of 200 microsecond, so we need to find the 50% duty cycle. T on is equal to T off, 200 microsecond divided by 2. So which is 100 microsecond divided by 1.085 microsecond. So divided by the step delay, the value is 92. The maximum value of the timer, since it is a 8-bit timer, the maximum value is 256. 256 minus 92, it is 164 to the base 10. Hexadecimal value is A4H. A4H to be loaded into the timer register. So in order to create 100 microsecond delay. Then the program is hash include register 51.h. So interrupt program, so interrupt 1 is used for generating the square wave. So hash include register 51.h, S bit in port 1.7, IND port 1.0. So receiving bit and then the same bit is transmitted. So receive the bit and transmit it. And the square wave is generated in port 2.5 of 8051 microcontroller. Okay. So this is the square wave program. So void timer 0, void interrupt 1. So this function, this interrupt function is executed once there is a timer overflow. If there is a timer overflow, it will this function is activated, executed. So the program start with void main. So SW is equal to 1, make switch as input port, T mod is equal to 0x, timer 0 is used in mode 2, then the initial value of the timer is A4H. In order to generate 100 microsecond delay of T on and T off, TH is equal to 0x, for A4 is hexadecimal value and exactly equivalent decimal value. Both it is possible, both it will accept, okay, embedded C programming will accept. Then start the timer, so start the timer to generate the delay, okay. Then I is equal to 0x82, that is interrupt enable. So interrupt 1 is enabled, okay, 0x82, so interrupt 1 is enabled, so enable interrupt for timer 0, okay, interrupt 1 is enabled here. So in order to generate the square wave, so we need interrupt 1, okay. So here while 1 IND is equal to SW, okay. So data is received and data is transmitted here, send switch to LED. So two tasks are done simultaneously. One is receiving a data from one port and transmitting the data to other port, and then simultaneously generating the square wave using interrupt programming, okay. So this is the another program, interrupt programming. So write a C program that continuously gets a single bit of data from port 1.7 and send to port 1.0, that is SWIND, okay. While simultaneously, number A, create a square wave of 200 microsecond, okay. Also into port 2.5, also sending letter A, that is serial communication, sending letter A to the serial port. 3 tasks are done here simultaneously using interrupt programming, okay. Use timer 0 to create the square wave. Assume the crystal frequency 11.0592 megahertz. Use 9600 baud rate, that is FD. We need to upload the initial value of the timer register 0x FD, okay. So for a square wave, the 100 microsecond delay we have to create, that is on delay or equal to off delay. So that value is 92. So 100 microsecond divided by 1085 step delay. In order to create, this is the step delay frequency. So 92, which is A4. A4 to be uploaded to create 100 microsecond delay, and 9600 baud rate. So 0x FD to be uploaded as the initial value in the timer register. So 2 timers we are going to use here. So for 2 interrupts, 2 timers is used. One for serial communication, one timer is for serial communication, the other timer is for creating the delay, okay. So the program start with including the register, then SW is declared, that is port 1.7, port 1.0, the square wave is generated in port 2.5, and this is interrupt 1. So interrupt 1 and interrupt 4, both is, so interrupt enable will be 0x92. Okay, in order to enable the 2 interrupts, we need to upload the value in interrupt enable register as 0x92. Okay, so interrupt 1 we generate the square wave, interrupt 4 we generate transmit the character A serially. Okay, so interrupt 1, wave is equal to not of wave in order to generate the square wave with 200 microsecond delay, and then interrupt 4, so where we will check the Ti is equal to 1. Okay, then SBuff is equal to A is placed in SBuff register and we make Ti is equal to 0. So the main program start with SW is equal to 1, make switches input, and T mod is equal to 0x22. So here both the timers are used, timer 0 and timer 1, both the timers are used in mode 2. So both the timer is in mode 2. Mode 2 means timer 0 is 8-bit auto reload and timer 1 is also 8-bit auto reload. For the first timer, the A4 value is uploaded, which is the initial value, in order to generate 100 microsecond delay. So equivalent value is 92. Start the timer 1. Okay, then start the timer 0 and then load a value TH is equal to 0xFD or 3 to fix the baud rate as 9600. Okay, these two timers, two timer has to be started. Timer 0 is started and timer 1 is started. So before this SCAN value is 0x50. Okay, so interrupt enable is 0x92. This makes enable both the interrupt 1 and interrupt 4. Okay, so the first function is while 1 IND is equal to SW. So whenever there is a overflow in the interrupt, that is overflow in the timer value from A4, the timer start, and the timer when it reaches FF, then there will be toggling of that is square wave. The square wave is equal to not of wave function is called if there is a overflow in the timer 0. If there is a overflow in the timer 1, then the complete bit letter A will be transmitted. Okay, thank you very much.